Alrighty, I'm gonna go back to calc. Do you remember doing this? E to the x? What's the derivative of e to the x? So you don't, right? So that means we probably haven't done it. We did do it though. You watched it as well. Like it was this video here. See this? We have done this.
Mm-hmm.
You remember this or no?
Kind of.
It's not that hard. Let's just do a few review questions and we'll kill this. Okay, understand the notation, all right? If you understand the notation, that's what math is basically. It's like a code. If you understand the notation, your life will be so much easier. So this is what you do, okay? Let's say you have some function y equals e to the f of x. Okay, where f of x for us right now is going to be x squared minus x. The derivative of this y prime is going to be the exact same thing, e to the f of x. Just drop it down times, okay, times f prime of x. You need to take the derivative of this exponent, okay?
Mm-hmm.
So if g of x is e to the x squared minus x, what's the derivative? The exact same thing is going to drop, okay, as it is, like that, okay?
Times 2x.
Close, 2x minus 1.
Mm-hmm.
Okay, this is called the chain rule component, chain rule. B is a product rule question. Whenever you have different functions multiplying with each other, that's going to be a product rule question. It's going to look something like this. Fg becomes f prime g plus fg prime, the product rule. Okay?
Mm-hmm.
You want to tell me what it will be here? What's f prime? If f is x squared, what's f prime?
2x.
2x times g as it is, right?
Mm-hmm.
What's g? G is your second function. Okay, this is f, this is g. So it becomes 2x times e to the x plus f as it is, which is x squared, times g prime. If g is e to the x, what's the derivative of e to the x? The derivative of e to the x itself, okay?
Mm-hmm.
The derivative of e to the x, it is itself. So times e to the x. Cool, that's it. All right, this one, they've given us f of x. Again, this is the rule. The derivative of e to the x is itself. I'm not going to apply to this question, but this one will apply. The derivative of f e to the power of some function f of x becomes e to the f of x as it is times the derivative of that exponent. So tell me, if f of x is 3ex squared, what's going on in this question? What's going to be f prime of x? By the way, the 3 is just a constant. If there's a constant here, it just drops as it is as well. No idea? Just drop the thing as it is, okay?
Mm-hmm.
So just drop it as it is, e to the x squared. You see, this is this component, e to the f of x. Now we need to multiply this by f prime of x, which means the derivative of the exponent. What's the derivative of the exponent?
2x.
2x, that's it. That is it, buddy. So the next one is f prime of negative 1. We already have f prime of x. We want to find f prime of negative 1, like that. We're simply going to replace this x and this x with negative 1. So it's going to be 3e to the negative 1 squared times 2 to the negative 1. So this will give you negative 6e squared. or not e squared, negative 1 squared is 1. So just like that, and that's it for this question. Cool.
Mm-hmm.
Is this hard? Or does this not make sense?
It makes sense.
Okay, just remember this is it. Once you have this, everything else is in the bag, basically. All right. This one. Determine the equation of the tangent line. So for this one, you're going to need a bunch of different things. Tangent line is just a linear equation, y equals mx plus b. Okay, x is already given, it's 2. You need to first find, I guess we can find our y value. If x is 2, what's going to be the y value for this function? So basically when x value is 2, right? What's the y value? How do you find that? Just for this function as it is. Just plug 2 in there, right? Like for example, x squared, y equals x squared. When x is 2, what's the y value? 4, right?
Uh-huh.
Same thing here. When x is 2, what's the y value? It'll be e squared, yeah?
Mm-hmm.
Over what?
2 squared.
Yeah, 4. So there you go. We have the x value that's given, it's 2. We have the y value that's given, or we found it just now, it's e squared over 4. But we don't have m and we don't have b. Next thing, you need to find your m, okay? M, the slope. How do you find the slope? You take the derivative of this, you take the derivative, and then you plug 2 in there as x. That will give you the m value. So let's find the derivative of this. Is this a product rule question?
No.
What rule is this?
Quotient rule.
Yeah, so remember, this is f, the top guy is f, the bottom guy is g. It's gonna be f prime g plus f g prime. This is the that's the product rule, actually. That's not the quotient rule, but it's very similar. It's gonna be minus f g prime divided by the original g squared. This is your quotient rule. So tell me, what's f prime? If f is e to the x, what's f prime?
Itself.
Itself. So you're gonna get e to the x times x squared as it is, g, minus f as it is, e to the x. What's g prime?
2x.
2x. All over g squared. If g is x squared, what's g squared? If g is x squared, what's g squared?
G to the power of 4.
Good. So not g, well, it'll be x to the power 4, right? G squared is x to the power 4. Make sense?
Mm-hmm.
This is just y prime. Next, we need to plug in 2 as your x value everywhere. So look at this, it's pretty simple. Wherever you see an x, just replace that with a 2. It's gonna look like this. Does the numerator become 0? You see,
Yes.
yeah. By the way, these are both constants. E is not x. Don't confuse E with x. E is like pi. It's a number. It's a natural number. It's 2.171 something. So even if they were not numbers, the numerator will still be 0. So you get 0 over 16, it's going to be a 0. So your slope, m, okay, this is how you find your m. You find the prime, you plug the x value in there. That's going to be a 0. Next, we need to find the b value. We know the m is 0. So let's plug everything in. E squared over 4 is your y value. M is 0, we just found it. X was 2, and b is what we're trying to find. So what is b equals to? How do you solve this equation for b?
You subtract 0.2.
It's not 0.2, actually, it's 0 times 2.
But wouldn't that just be 0?
That'll just be 0, yeah, so you can just ignore this. So b will simply be e squared over 4. Okay, that's your y-intercept, right? So therefore, the line, your straight line is 0x, your slope is 0, 0x, plus e squared over 4. If the slope is 0, what does that mean? Remember, this is a tangent.
It's a straight line?
It is a straight line, yeah. But for this function, right, you see this function? This one, we don't know what it looks like. We don't really care. But if you really graph it out, when x is 2, you're going to get a turning point. Okay, we don't know which way it's turning, but you're going to get a turning point because the slope is 0. Okay, turning point means the slope is going to be 0. So it's turning downwards, yeah, right there. Make sense? Okay, let's do a tricky question. So they've given us a function. We need to find the derivative, the first derivative, and then we need to plug 1 in there as the x value. What is the idea here? How would you find the derivative of this? Any ideas? It's a trick question, okay? You just open the brackets. Maybe it will make your life a little bit easier. Let's open the brackets. Just throw 1 over 3 in there. It's going to become 1 over 3 e to the 3x plus 1 over 3 e to the minus 3x. What's the derivative of 1 over 3 e to the 3x? No. Again, remember, e to the anything, the derivative is itself. So you're going to literally drop that down as it is. What's the derivative of the exponent? What's the derivative of 3x? It's going to be 3. Okay. 9x, the derivative would be 9. Pi x, the derivative would be pi. What's the derivative of the second guy here?
You just read it again?
Yeah. And what do you multiply them? Multiplied by?
-3.
-3, that's it. What's next? You're going to plug 1 as x value, okay? So 1 over 3, e to the 3 times 1 is e cubed times 3. This 3 and this 3 cancels out. Plus 1 over 3, e to the -3 times 1 is -3 times -3. This and this cancels out. Get e3 minus e to the -3. Is that 0?
No.
No, it's not. This is actually e to the 3 minus, you see the negative exponent? We can toss it in the denominator to make it positive. What's the LCD between these two? It's this guy, yeah? This guy one has an invisible one. It means you need to multiply this by e3. You need to multiply this by e3. So they both have a denominator of e3 minus 1. Do you remember your exponential rules? What's e3 times e3?
E to the power of 6.
Yeah, there you go. It's not 0. This is going to be the answer. Or you can even leave it like this if you want. That's how you find the derivative. It's not too difficult. Here, look at this. It may seem daunting, but it's not. Straight up, I know the derivative of this. I'm just going to drop it down. The tricky part for this one is going to be to find that what it multiplies to. So we have 1 over x plus 1, okay? This is f, this is g. This is going to be a quotient rule question. So it's going to be f prime g minus f g prime over g squared. What's f prime? What's the derivative of 1? The derivative of any number is 0, okay?
Mm-hmm.
So you have 0, so f prime is 0, 0 times g, 0 times x plus 1 disappears. Minus f, which is 1. What's the derivative of the denominator? What's g prime if g is x plus 1?
It's 1.
That's 1, good. All over what?
X plus 1 squared.
Yeah, x plus 1 squared, there you go. And this negative sign here comes down as this negative sign here. So negative 1 times negative 1 is a positive 1, so you have e to the negative 1 over x plus 1 times 1 over x plus 1 squared. There you go, that's the derivative. The next part, it's asking us to find f prime of 0. We're simply going to replace this and this with 0. So it's going to become e to the negative 1 over 1 is just 1 times 1 over 0 plus 1 squared is just 1. So the answer is e to the negative 1, or 1 over e as the final answer. Cool?
Mm-hmm.
In other words, 1 over e, okay, it's going to be some number. It's going to be 0 point something. That's the slope of the tangent line for this function when the x value is 0. So what does that look like? It's going up. It's gonna go down like this, I think. So this is f of x when the x value is 0. Okay. Actually, it has to be positive. It's because that one will be negative. Probably looks something like this. It doesn't really matter what it looks like. When the x value is 0, the slope of this tangent line is gonna be 1 over 3. Cool.
Mm-hmm.
That's what that means. The slope of the tangent line is 1 over 3. What rule do we use here? Again, we're trying to find the derivative.
Do you open the brackets first?
You can do both. Yeah, you can open the bracket if you think that's fine. Yeah, it's gonna work. It's gonna work either way, so it doesn't really matter. So there you go. This way, I'm not taking the derivative, so we simply open the brackets. Now let's find the derivative. What's the derivative of z squared?
2z.
2z is right. What about the other one? What rule do we use? You got this, actually. It's gonna be a product rule question because you have two different things multiplying to one another. Any ideas? Again,
Do you write 2z again?
yeah, you write 2z again. What do you multiply that by? We're using the product rule.
Negative z.
And negative z plus what?
Negative 1.
So again, you have f prime g. Okay, next you're gonna have f g prime, where this is your f and this is your g. Right?
Mm-hmm.
F, you're gonna rewrite z squared again times g prime. G is e to the negative z. What's gonna be its derivative?
Itself.
Itself, yeah. What about the chain rule component? What's the derivative of minus z?
Is it minus 1?
It's minus 1, yep. It is indeed minus 1. There you go. That's the derivative. Next, you just plug z as 1 everywhere you see it, or sorry, -1. So this is going to be -2 plus 2 times -1 times e to the +1 plus -1 squared times e to the +1 times -1. So you get -2 minus 2e minus e. Looks like you'll get, so you get -2 minus 3e, and that's the final answer. So yeah, this is just a product rule. This is nothing fancy going on here. Fg, f prime g, g prime f. The only difference is that the derivative of e is itself. This is going to be like a math question when you're writing, like, not a school math exam, but like when you're doing like a different type of entrance test or something. Okay, we'll take it one thing at a time. It's not difficult. Y is e to the -3x. What's going to be y prime, which is just a derivative of this guy?
Itself.
Yeah, and then what do you multiply this by, if anything?
-3.
-3, that's right. Now the next part, do you see d squared y over dx squared? This thing? It's asking you to find the second derivative. So you find the derivative of this. What is that going to be? Again, it's going to be itself, right? It's going to be itself. Nothing changes. What do we multiply it by? What's the derivative of the exponent?
-3.
-3, yeah. So -3 times -3 would be -3 squared, like that. You want to tell me what triple prime is? Which is going to be the derivative of this.
You write the same thing.
Yeah, what changes?
It's -3 cubed.
Cubed, yeah, there you go. That's part A, okay? Tell me the answer to part B. What's the pattern that we found? What's going to be y to the power of n, which means the nth derivative. What changed? Look at this. What changed from here to here, here to here? What changed? Only one thing changed.
The exponent.
The exponent. So the nth derivative of y is going to be what?
The exponent is n.
Yeah, the n. There you go. That's it. That's it. It's pretty easy. But again, you have to think about it a little bit. Let's find, it says find y and find y prime. Sorry, it says find y prime and y double prime. First and second derivative. How would you find the first derivative? Multiple ways to do this. You
Should
can
you open the bracket?
Yeah, you can open the brackets, or you can also do it without opening the bracket. So you have this. What's the derivative of 4e to the x?
Itself.
Yeah. What about the second guy? What do we use? Notice how there's multiple things multiplying. Which rule do we use when that happens? Product rule, no? Okay. This is f. This thing is g. What's f prime?
1.
Times g as it is. Plus, but notice how there's a minus sign here. So even though there should have been a plus here, that minus and plus becomes this. This becomes a minus. So right now we have f prime g plus, or it's gonna look like this actually. Let me just do it this way. Plus, what's f x? What's g prime?
Itself.
Itself, right? So like this. So when you do this, you're gonna get 4e minus 1e to the x will be 3e to the x. 4 apples minus 3 apples plus x e to the x. So there you go. This is y prime. Now the question says find y double prime.
You write itself.
Yeah, the first one is gonna be itself, so it's gonna be 3e to the x. What about the second one? What's the derivative of the second one? We already found it in the previous part. If you look at it, you'll see it. You gotta use the product rule there, right?
Mm-hmm.
So what's the derivative of x e to the x?
It's e to the x.
Yeah, it's e to the x plus x e to the x. We already found this before. So 3e to the x minus e to the x is 2e to the x. And this plus and minus becomes a minus x e to the x, and you're one and done. Make sense?
Mm-hmm.
The next question has to do with bacterias. Are you a fan of bacterias? I don't know what that question even means, but when you think of bacterias, you're thinking of like the bad things, right?
Yes.
But there's good kinds of bacterias as well in life. In fact, a lot of them are inside us at any given time on our skin. The food that we eat, some of them have bacteria on them as well. Like cheese and stuff, they have bacteria in them. It's not a bad thing. Not all of it anyways. Not everything is black and white. Anyways, they have given us a function where n is the number of bacteria and t is the hours. So as the hours go up, the bacteria are gonna go up as well. What is the initial number of bacteria? So we want the bacteria right now. Not after t hours, but right now.
Is it 1,000?
It is not. Is it 1,000? No, it's not. Why is it not? Look at where the t is. You're not taking into account where the t is. So for A, all you need to do is you need to find n of 0, okay? At time 0, what's the value?
Mm-hmm.
It's going to be 1,000 times 30 plus e to the negative 0 over 30. E to the negative 0 is just going to become, this is just going to become e to the negative, e to the 0. 0 over 30 is just e to the 0. What's e to the 0? What's anything to the power of 0?
1.
1, right? So it's going to be 1,000 times 31, 30 plus 1. It's going to be 31,000, not 1,000. Make sense?
Mm-hmm.
31,000. It would be 1,000 if it was like 1,000 times e to the t. Yeah, this one would be 1,000. This one, they've added some extra things for us. Determine the rate of change in the number of bacteria at time t. What does rate of change mean?
The derivative.
The derivative, yep. So we need to find n prime of t. So I know you like opening the brackets. Let's do that. That makes it easier as well. It's going to become 30,000 plus 1,000 times e to the negative t over a 30. So this is just nt. Let's find its derivative. What's the derivative of 30,000?
0.
0. What's the derivative of 1,000 e, the other term?
Itself.
Itself? Do you multiply it by anything?
By the exponent.
So times t over a 30? Times by what? What's the derivative of minus t over 30? because this is our f of x. We need to find f prime of x. What's the derivative of 2x? Just drop the letter, yeah? Like this, 2x becomes 2. Negative 2x becomes negative 2. Negative 1 over 2x becomes negative 1 over 2. Just drop the letter. If it's power 1, okay, you drop the letter. So right now we have minus t over 30. You can think of it as minus 1 over 30 t. What will be the derivative?
Negative 1 over 30.
Yeah, negative 1 over 30. Like that. So this and this cancels out. You get a negative 100 over a 3 e to the negative t over 30. So the rate of change has a negative slope. So is it going up or down?
Down.
It's going down, yeah. So it's decreasing in this culture. C, how fast is the number of bacteria changing when t is 20? For C, all you need to do is you need to find n prime of 20. We already have n prime here, so let's just plug a 20 in there. Negative 100 over 3 e to the negative 20 over 30, whatever this answer is. Negative 20 divided by 30, I got negative 17.11. What does that mean in the context of this question? Which is also the answer to part E. At t equals 20, yeah, hours, right? The rate of change of bacteria in this culture is going down by 17.11 bacterias per hour. Okay, that's what it means. So every hour they're losing 17 of them are dying. That's what it is.
Okay.
Determine the largest number of bacteria in the culture during the interval 0 to 50. It's a trick question. I'm telling you right now, for D, you don't even need to do anything. The answer is in front of us. Remember, it's going down, okay? As soon as the clock started ticking, it started going down. So when was their population the highest?
At 0.
At 0. How many did we have at 0?
30,000.
31,000, yeah. Because e to the negative 0 is a 1.
Mm-hmm.
So 31,000 is the answer to D. What about E?
The number is going down.
Yeah, the number is going down. E to a negative exponent means it's a shift, it's a reflection on the y-axis. So this is where you started off at 31,000, and then your bacteria is going this way. Is it ever going to hit 0?
Yes.
No, it does not. Exponential functions never hit 0. Okay, there's like an invisible wall here called an horizontal asymptote. When the variable E is not a variable, okay, T is the variable. See, N is a function of T. E is just a constant. You can replace E with 2.171 something. When the variable is in the exponent, it becomes an exponential function, and exponential functions never hit 0.
Okay.
We're not doing any of this other junk. This also, we've kind of done this last time. Look at this. A to the f of x. Okay, let's say this is our function, where a is now a constant. It can be anything. It's not just limited to e. The derivative is going to be itself, okay, times the derivative of the exponent. Same thing as last time, almost. One new addition, that's going to be times the ln of a. For example, y is, let's say it's 2 to the power of x squared. So now a can be any number, okay? Doesn't have to be e. Y prime is going to be itself 2 to the power of y x squared. What's the derivative of the exponent?
2x.
2x times ln of the base 2, this base.
What's ln?
Ln is the inverse function of e to the x. Ln
Okay.
means the natural log. So e to the x is this function, exponential function going up. Ln of x is the inverse function. This one is ln of x. This one is e to the x. 10 to the power of x looks like this. It's very similar to e to the power of x, but it grows a little bit quicker. So this would be 10 to the power of x. The inverse of 10 to the power of x is log of x. See, log goes with 10. Ln goes with e. That's the difference. It has the same properties as log. Will never be 0. And it's always going to go up. Okay, using what we just learned, the formula, what's going to be the derivative of this?
First, you write itself.
That is correcto. Let's do that. Then
Times 3.
times 3 is right. Yeah. Anything else?
You do the ln thing.
Yeah, multiply by ln of what? 5. Cool. Make sense? That's literally it. I mean, we're gonna do some other questions here, but that's the gist of it. They don't even have that many questions. Oh, this is gonna throw you off. Or is it? I don't know. There we go. Looks like we have a quotient rule problem because there's a numerator, there's a denom. What we do here? So again, this is a quotient rule problem. It's f over g. So it's gonna be f prime g minus f g prime over g squared. If f is 3x square root, what's f prime? How do you even find this? Any ideas? You're gonna do it like this. You're gonna rewrite f as, what does square root mean? To the power of what?
1/2.
Yeah, it means to the power of 1/2, right? So you're gonna rewrite this as 3 to the x to the power of 1/2. What's next? Then we're gonna use the power rule like we did before. So f prime, you see this exponent? This is gonna drop as it is. Nothing changes inside. Okay, like that. Then you take 1 away from this. Like we did with x cubed, it would become 3x squared. Same thing here. You take 1 away from this. 1/2 minus 1 is negative 1/2. Okay? That's not all though. Then you need to multiply it by the derivative of the bracket. What's the derivative of 3 to the power of x?
It's 3 to the power of x.
Times what? Ln 3. Okay, see, this is a chain rule component, which is the derivative of the bracket, but then you got to use the bigger picture of the power rule when you have a function inside a function. So this means f prime is going to be this entire thing, 1/2, 3 to the x, negative 1/2 times 3 to the x times ln 3. That's just f prime. times g as it is, so times x squared, minus f as it is, so minus root of 3 to the x, times what's g prime?
X to the power of 4.
No, that's g squared. We're trying to find g prime. We're here. So it's gonna be times 2x all over x to the power of 4. There you go. And that's gonna be the answer.
Okay.
Make sense?
Mm-hmm.
We're not gonna do optimization right now. We're gonna jump into a fun, we're gonna start, I mean, it's the same topic, but we're gonna look at a different thing. And it's gonna throw you off, hopefully. It'll be fun though, it'll be fun. So we've seen sine and cosines before. Well, we haven't talked about what their derivatives are. It's very simple. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. That's the big picture, okay? But you have to take into account the chain rule component. What does that mean for us? Let's look at these two questions. We know the derivative of cos is sine, yeah?
Mm-hmm.
You just treat this as a bracket. The derivative of cos is negative sine, so it's going to be negative sine of 3x. What's the derivative of the bracket?
3.
3. There you go. That's the chain rule component, and that's it for this question. Let's look at B. It's going to be a product rule question. Tell me, what is it? You know it. What's f prime? F is x.
It's 1.
1 times g as it is plus f as it is. What's the derivative of sine? Look up there.
Cosine.
Cosine. There you go. That's g prime, and that's it. You're done. Sine becomes cosine, but cosine becomes negative sine. Sine x squared. You want to have a go at it? What's y prime? Remember, sine becomes cosine. Sine right now, whatever is in the bracket, okay, whatever the angle is, it's going to become cosine of whatever the angle is, but then you have to multiply it by the chain rule. Cool?
Mm-hmm.
So sine becomes cos, right? It's going to become cosine of x squared. What's the chain rule? What do we multiply this by?
2x.
2x, that's it. This one's a little bit complicated. Sine squared x means, okay, I'm not finding the derivative, I'm just rewriting it. Sine squared x, it basically means sine x whole squared, like that. So this is actually a power rule question, okay? It is a power rule question. You want to have a go at it? First, use the power rule by bringing the 2, and then you have to multiply it by something as well. What'll be the derivative?
Do you bring the 2 down first?
Yeah, 2 down. What about the inside? Does it change?
Does it turn into cosine?
No, that'll be later. So the power rule, nothing changes on the inside. For example, if you have 3x plus 5 to the 5, it's going to be 3x plus 5 to the 4. Nothing changes here. But then later you'll multiply it by a 3. Same thing here. This thing doesn't change. This thing becomes a 1. What do we multiply it by?
Cosine.
Cos x. There you go. That's it. Same thing here. Yeah, don't worry about it too much. Cos becomes negative sine. So y prime will be what? Negative sine. Does the bracket change? The bracket represents the angle. It does not change, okay?
Mm-hmm.
What do we multiply this by?
3x squared.
3x squared is right. That's it. One and done. Easy peasy. All right, now they've combined it, but we got this. It's nothing's gonna change. Remember, this is an e function now. What's the derivative of any e function? It was this, right? E to the f of x becomes itself, but then you got to multiply it by the derivative of that exponent. What will it be here?
Itself times cosine.
Plus this times cosine, that's it. What about the derivative of this?
Minus sign.
Yeah, minus sign like that. That's it. One-step answer. Equation of the tangent line. So again, tangent line equation, when they ask you, you need y equals mx plus b. X will usually always be given to you in the question. X is given. For this function, I want to find the y value when the x value is pi over 2. What do I do? Maybe for our sakes, I don't know if we've done radians. I think it was a long time ago. Let's say x is 90 degrees. Pi over 2 is 90 degrees. I want to find the y value when the x is 90. What do I do?
Do you plug in 90 as x?
Yeah, you plug in 90 as x. I'm going to plug this. Actually, let's stick with radians. You plug in pi over 2 as x, yeah? Pi over 2 as x. So cos of 2 times pi divided by 2. Cos of 180. Okay, I plugged it in the calculator. I get negative pi over 2. So that's the y value, okay? We have y value, we have x value. Next, let's find m. Do you remember how to find m? M is the slope. The slope of the tangent line m is simply f prime of x. You're going to find the derivative. You're going to plug the x value in there. Okay? What will be the derivative of y here? You got to use the rule, product rule. So f is x, g is cos 2x. What's f prime?
1.
1. G as it is. Plus f as it is. What's g prime?
Negative sign.
Yeah. So negative sign of what? What's the angle? Negative sign. The angle doesn't change, yeah? 2x. What do we multiply that by? What's the derivative of the inside bit?
2.
2. There you go. That's y prime. And you're going to plug x as pi over 2 in all the x's to find the slope. So cos of 2 times pi divided by 2 plus pi divided by 2 times negative sine of 2 times pi divided by 2 times 2. I got negative 1 as my slope, as my m value. Remember, this is your m. Once you find the first derivative, once you plug the x value in there, that'll give you the m. Next, we're going to plug everything in here to find the y-intercept. So the y value we found it earlier was negative pi over 2. M we found it right now, it's negative 1. The x value is pi over 2 plus b. How do we find b? How do you solve this equation for b?
You add 1.
No, you cannot add 1. They're being multiplied here. First of all, what's negative 1 times pi over 2? What does that simplify to?
Pi over 2.
Negative pi over 2. There you go. Now what? You're going to add pi over 2 on both sides. Okay, you need to get rid of this. When you add them, you're going to get a 0 because they're the exact same thing. 3 equals 3 plus x. These two cancels out. Same thing here. B is 0. So the y-intercept is 0. That means it's going to go through the origin. Therefore, for the final answer, it's going to be y equals m is -1, x is x, b is 0. There you go. Y equals -1, x is the answer. It goes through the origin because the y-intercept is 0. Let's do a couple of them actually. Let's do 4 of them. And we will probably be done. All right, this one. You want to have a go at it? It's a sine function. What's the derivative of any sine function?
Cosine.
Cosine. Within the chain rule element, what's the derivative of the bracket?
Itself.
Itself. So there you go. It's going to be cos to the x times e to the x. What about h? We have a sine function. What will be the derivative?
3 cosine.
3 cosine, yeah. Does the bracket change? Does this change?
No.
No, it does not change. What do we multiply this by? What's the derivative of the bracket, basically?
Three.
Okay, not 3 plus 2?
No.
Yeah, why not? What happened to the 2 pi? You're right. What happened to the 2 pi? It's a constant, okay? The derivative of a constant is this here, so you ditch it. Okay, the next one, I squared. Very simple. X squared, I'll do it, 2x. What's the derivative of cosine x?
Negative sine x.
Yeah, negative sine x. What about sine pi over 4?
Cosine.
Okay, so you got it right here. Use the same idea. Sine pi over 4. Is there any variables here? Is there any x's?
No.
So what is this? This is just a constant, okay? This is sine of some angle. Sine of 45, it's going to be 1 over root 2. That's just a constant. The derivative of that would be 0. Ignore it. J. The derivative of sine is cosine 1 over x, right? Then we need to multiply this by the derivative of the bracket. How do we find the derivative of 1 over x?
Do you turn that into like x to the power of -1?
Okay, yeah, we can do that. What will be the derivative of that? It's just a power rule thing.
Is it -1?
Well, so -1 comes down here, -1 x. Then you gotta take 1 away from this. X to the -2, like that. That's it. That'll be the derivative of 1 over x. So there's no chain rule component because there's only x. Chain rule is when there's a function within a function, like here. See, we have a linear function within a sine function. That's why chain rule. Same thing here. E function within a sine, chain rule. But if there's just one function to start off with, there's no chain rule. And that is it for this question. How is sine cosine derivatives? Difficult?
No.
All right, let's pick it up tomorrow.
All right. Thank you.
See ya.